This video is on rational expressions. Rational expressions are rational problems that do not equal anything. So notice that both of the problems that you see on your screen do not have equal signs. That's because the most you can do with rational expressions is simplify them. You cannot solve them because we have no idea what they equal. There is a special note that you need to know about rational expressions, and that is that the domain excludes values that make the denominator 0, and it also excludes any wholes. Now, for something to have a whole, it must be the same in the numerator and in the denominator. So when I mean same, if I look at this first problem on the left, notice that I have x squared and x squared. Well, those are not the same because x squared plus 6x plus 5 is all one piece together. And x squared minus 25 is all one piece together. They are not the same problem, so I can't just cancel out the x squareds. So what I need to do to find out if I have any wholes is I need to factor them. Now if I look at the top, I could do a quick little factor tree, and I have 5 on the top, so I'm going to have 1 and 5. And I want it to add up to 6. Well, they do, so I have x plus 1 and x plus 5. Now on the denominator, I can see that both of them are squared terms, and it's subtraction in the center. So this is a case of difference of two squares. So I get two parentheses with the exact same thing in them, except one gets a plus and one gets a minus. The square root of x squared is x. The square root of 25 is 5. Now I can see if I have any like terms. So when I'm looking for like terms, I'm looking for the same thing inside the parentheses. In this case, notice that x plus 5 and x plus 5 are the same. That means that I have a whole at x equals negative 5. I got x equals negative 5 because I took the parenthesis that we marked out and I set it equal to 0. And when I solved, I got x equals negative 5. So I know that there is a whole at x equals negative 5, so that is excluded from our domain. And my problem left is x plus 1 divided by x minus 5 as my final simplified problem with a whole at x equals negative 5. And I also have to remember that the denominator cannot equal 0. So I have x minus 5 cannot equal 0. So x cannot equal 5. So my domain can be written as all real numbers except plus or minus 5. Now that covers the 5 and the negative 5. So let's try another problem. So notice that this problem is a little more difficult because this time we're dividing. We're not solving, we're just dividing. Well, remember that we can't do division of fractions, so we're going to keep the first fraction. We're going to change the sign to multiplication, and we're going to flip the last equation over, or the last problem over. Now when we flip, we really mean take the reciprocal. Reciprocal and flip mean the same thing. Well, before we can do any of that, we need to simplify it. Well, the second term is already simplified, x minus 4, x plus 3, but the one on the left is not. So on the left, I know I'm going to need a factor tree with negative 8 on the top, and we're going to get x squared minus 2x minus 8, so 8 can be 2 and negative 4, and that would add up to be negative 2, so I have x plus 2 and x minus 4. On the bottom, I notice this is also a case of dots, just like the last problem. So one gets a plus and one gets a minus. The square root of x squared is x. The square root of 9 is 3. So from here I can see that nothing can be simplified. So we're going to change to multiplication, and we're going to flip the second term over. Now I have x plus 3 and x minus 4. Now if it helps you, you can put these all in parentheses. And anytime we do multiplication, it's like multiplying all the way across. So I can compare all the parts on the top and all the parts on the bottom. So I notice that we have a positive 3x plus 3, and we also have an x minus 4. Those are our wholes. So we have wholes at x equals negative 3 and positive 4. Again, remember that we would have to set both of those equal to 0 and solve and get x equals negative 3 and x minus 4 would give me x equals 4. So now we have our wholes, and we can finish simplifying our problem. So we have x plus 2 over x minus 3 as our final simplified answer. And we know that the domain will be, so we have to decide, we have wholes. We also have to include the domain down here. We know that x minus 3 cannot equal 0. So the domain is going to be, this means x cannot equal negative 3. Oh, cannot equal positive 3. Okay, so the domain is going to be all real numbers except plus or minus 3 and 4. So it's really all of those values. And you need to have a completed simplified answer and the domain to have a correct answer for these types of problems. We're going to look at one more type of problem. Now this problem may look harder than the other two, but it's not really any more difficult than the last one. So what we want to do first is write this so it's more user-friendly. Right now this looks scary. Well, we don't want it to look scary. We want it to look simple. So we're just simply going to write the top part below. We have 1 plus 1 over x in parentheses if you want. And notice it's divided, so let's write it as divided. And then we have the bottom. So we have 1 minus 1 over x. Now before we can actually do keep, change, flip, we need to simplify these fractions to make one fraction. Notice that I have 1 and 1 over x. So they have to have a least common denominator, so I can change this 1 to x over x, because a number over the same number equals 1. Plus 1 over x is divided by, same thing here, x over x minus 1 over x. Now that I have a common denominator, I can add the tops and keep the bottom. Now I have one fraction, which is much easier to work with. For the second term, I have x minus 1 over x. Now we can do keep, change, flip. So we're going to keep the first term. We're going to change this to multiplication, and we're going to take the reciprocal or flip the second term. Now we can look to see if there's any way that we can simplify it. Well, in this case, notice that I have an x and an x. So those cancel out, and I know that I have a whole at x equals 0. So now I can finish simplifying my problem. So now I just have x plus 1 over x minus 1. And this is my simplified answer, but remember I have to include the domain. So since the domain is x minus 1, I know that x minus 1 cannot equal 0. Therefore, x cannot equal 1. So my domain can be written as all real numbers except 0 for my whole and 1 for my excluded domain. Now we want to talk about one more thing. If I put these on a number line, let's talk about how to write them in interval notation. So we know we have a couple points. We have 0 and we have 1, and they cannot be included. So those would be circles on a number line. Remember, we only get dots when those values are included. Well, we don't want to include these. but we know we have everything to the left and to the right of these points. So if I wanted to write this in interval notation, I'd start at the left, and I have parenthesis negative infinity. This stops at 0, but 0 is not included, so it gets a parenthesis, union, parenthesis, 0 to 1, also a parenthesis, union, 1 to infinity. So again, this is called interval notation, and you should be able to write your answers for domain in either the written version, all reals except 0 and 1, or interval notation.